A very warm welcome to the class, children. So today's topic is study of sound part 2. In the previous video we have studied about the longitudinal waves, the transverse waves, the characteristics of the sound waves, the velocity of the sound, and also studied that the velocity of sound is different in various mediums. So do you think that the velocity of sound is different during the summer season or during the winter season or during day or night? Yes. There are certain factors which affect the velocity of sound in the gaseous medium which we are going to study today. So the first factor is the temperature. How does it affect? How does the temperature affect the velocity of the sound? The velocity of the sound is directly proportional to the square root of the temperature of the medium. If I have to give an example, suppose this is a speaker, this is a gaseous tube, okay, and the molecules are moving away from each other. You know, in a gaseous tube, the gases molecule always are moving away from each other. The speaker is on, so the particles start moving. If I put a burner, okay, below it, if I put a burner under it, what would happen? The particles would start moving more. Why? Because the temperature has increased. So the particles start moving away from each other more. That is, the particles move faster. When the particles move faster, that means their velocity increases. So when does this velocity increases? When the temperature is being increased. Okay, when the temperature is being increased. So what does it say? It says that the velocity of sound is directly proportional to the square root of the temperature of the medium. What does this mean? That increasing the temperature 4 times, that is, when you increase the temperature 4 times, it doubles the velocity. So it is given as V is directly proportional to the square root of T. Okay, so directly proportional means as the temperature increases, the velocity also increases. But how many times? This means that it increasing temperature 4 times, then it doubles the velocity. Okay, understood? So this part is very important, that V is directly proportional to root T. Okay, so this is an example they have given. When it is cooler, the sound travels much slower, and when it is warmer, the sound travels faster. Okay, understood the factor which affects the velocity of sound, that is temperature. Okay, next, the next factor is the density. Now you can see in this picture, here the density of particles is less as compared to here. So because of packed, that is, the particles are quite closely packed towards each other, the sound waves would not be able to travel faster. So that is why the velocity of sound is less when the density is more. Okay, the velocity of sound is less when density is more. So in physics terms, it is given as the velocity of sound is inversely proportional to the square root of density. So that means if density increases, your velocity of sound would decrease, and vice versa. So thus the increasing the density 4 times reduces the velocity of half its value. So it would be half. So it is written as velocity is inversely proportional to 1 upon rho. Okay, it is inversely proportional to 1 upon rho. Inversely only indicates that one thing increases, the other thing decreases, and vice versa. Okay, so till now we had done about temperature and density. Temperature is directly proportional to the square root of the temperature. The velocity of the sound is directly proportional to the square root of the temperature, and whereas in terms of density, the velocity of sound is inversely proportional to the square root of the density. Okay. Next factor is the molecular weight. Now what do you mean by the molecular weight? It is the weight of that particular molecule, the addition of all the atomic masses. If H2O is considered, the atomic masses of both this is calculated, so that becomes the molecular weight of that particular molecule, okay, of one H2O molecule. So what happens in the molecular weight? The same way, if I have to give an example, that this is the molecules which are there. Okay, if the molecular weight is increased, the speaker, the sound waves have started coming. If the molecular weight is increased, what would happen? It would not be able to move again. The sound waves would not be able to move faster. So again, it becomes inversely proportional. So when molecular weight increases, the velocity of sound decreases. So the velocity of sound is inversely proportional to the square root of molecular weight of the gas. So more the molecular weight, they are not able to move, thus increasing the molecular weight 4 times reduces the velocity to half its value. So it is given by V is inversely proportional to 1 upon root m. Got it? So 3 factors we studied till now: temperature, density and molecular weight. Density and molecular weight are both inversely proportional, okay, to the square root of its respective, whereas temperature, it is directly proportional, okay, to the velocity of the sound. I hope I'm clear about the 3 factors that affect the velocity of sound in the gaseous medium. Okay, let's solve this. The molecular weight of oxygen gas O2 is 32, while that of hydrogen gas is 2. Prove that under the same physical conditions, the velocity of sound in hydrogen is 4 times than in oxygen. Okay. So we know that velocity is inversely proportional to 1 upon root m. Now they have given the molecular weight of H2 and oxygen. So we'll just substitute it. That is root 32 upon 2. So 2 ones are 2, 2 16s are. So root 16 gives us 4. So that means velocity of hydrogen upon velocity of oxygen is equal to 4 upon 1. So if we cross multiply, it appears as velocity of hydrogen is equal to 4 times the velocity of oxygen, and hence we have proved that the velocity of sound in hydrogen is 4 times than in oxygen. Now let's study what are the types of the sounds. These types of sounds are based on the frequency, and frequency is calculated in hertz. This Hz represents hertz. Okay, so there are certain sounds which are that we are able to hear, and those sounds are called as audible sounds, and their range of frequency is between 20 hertz to 20,000 hertz. So any frequency between 20 hertz to 20,000 hertz, we are able to hear those sounds, and they are called as audible sounds. But there are certain sounds, that is infrasound, whose frequency are smaller than 20 hertz, and we are not able to hear those sounds. Okay, we are not able to hear those sounds. For example, they have given as a pendulum. We are not able to hear the sound produced by the sound produced by a pendulum. Then there are certain sounds whose frequency is greater than 20 kilohertz. They are called as ultrasounds. Okay, so understood, there are audible sounds which are between that we can hear, the human ear EAR can hear, that is between the range from 20 hertz to 20,000 hertz. They are called as audible sounds. Then there are sounds which are smaller than 20 hertz. They are called as infrasounds, and there are certain sound waves whose frequency is greater than 20 kilohertz, and they are called as ultrasounds. Okay. Now the dog, mouse, bat, dolphin, etc. have a special ability to hear this ultrasonic sounds, that is this ultrasound. Thus they can sense some noise which are inaudible to us. That means we are not able to hear those. Children under 5 years of age and some creatures and insects can hear waves with frequency up to 25 kilohertz. Bats, mice, dolphins, etc. can also produce ultrasounds, okay, to have the communication, or to detect any predator. So for that they produce the ultrasonic sounds. So am I clear? Let's look up to the ultrasounds, which we studied, we just read about it, that the bats, how they produce the ultrasonic sound. So there was this scientist named, Italian scientist named Spallanzani. How did he find out that whether how the bats could even see during the dark? They can see in the dark also. So how did he understand that, how even though in the dark, how they are able to see? So the Italian scientist Spallanzani was the first to discover a special mechanism present in bats. He covered various organs of bats because that time he was not aware. So like the eyes, ears, nose, etc. One by one. That means once he only covered their eyes, then once he only covered their ears for doing this experiment. One by one, and allowed them to fly in the dark, thereby discovering how they can fly easily in the dark. He found that the bats with their ears covered began to collide with whatever came in their path. So when their ears were covered, they started colliding. Colliding means they started dashing it as if they were not able to hear it. Okay, even though their eyes were open. So their eyes were open but their ears were closed and they started colliding. So this showed that they did not use their eyes for looking or seeing into the dark, but they used their ears. They were of no use to the bats. The eyes were of no use to the bats. Even though they were open, still they were colliding. He thus discovered that their ability to fly in the dark depends on their ears and not eyes. The ultrasonic sounds which are produced by the bats get reflected on hitting an obstacle. That means if this is the bat and this is that obstacle, the sound waves, ultrasound waves are being sent. So when it is hit, that means there is an obstacle, so it comes back, it is reflected back. Okay, so it understands, okay, at this particular distance there is an obstacle. So this reflected sound is received by their ears and they can locate the obstacle and estimate, that means find out its distance even in the dark. So they send the ultrasonic waves. So if this is the obstacle here, the ultrasonic waves dashes to that obstacle and comes, reflects back, and they hear the sound. So this is how they hear, even they could see through the dark, but not through their eyes but through their ears. Okay, this was how the bats use the ultrasonic sounds. But how we use, how this applications of man-made uses of it? Cleaning purposes. There are big instruments or these big machines. They cannot be cleaned by putting their hand inside it. No, you need require something. So this ultrasonic waves are being sent it through this high frequency ultrasonic waves are being sent, so that the cleaning occurs in that particular machines. For finding out the heartbeat, that is called as echocardiography. Okay, then ultrasonography. All the internal organs of your body can be found out through this ultrasonic waves by sending the ultrasonic waves, and then a picture of these internal organs are being flashed onto the computer screen. That is the latter part we are going to study about it. Then in big machines, if there are any cracks, that also can be found out, and breaking of the kidney stones can also be done with the help of these ultrasonic sounds. So for uses of ultrasonic sound, some more uses and the same ones which can be added up. More communication between the ships at sea. That is, we are going to study in the latter part again about the sonar, that if more communication between the ships at the sea, if the ship has to understand that how deep there is a glacier, or there is a kind of an object which might hit that particular ship. So for that, these ultrasonic sound waves are sent, so that they dash to that particular object and they are reflected back, and they can receive the transmission, so that we understand, okay, there is a particular obstacle which we need to be careful of. To join the plastic surfaces together. To sterilize. Sterilize means to make it pure, the liquids like milk, by killing the bacteria in it, so that the milk keeps for a longer duration. So making the milk free from the bacteria, that is called as sterilization. Echocardiography, which I just mentioned, which studies the heartbeats. It is based on the ultrasonic waves, the sonography technology, that is called as, to obtain the images of internal organs in a body, in a human body. to industry to clean the intricate, means very small inside parts of machines where hands cannot reach, and to locate the cracks and faults in the metal blocks. You cannot every time remove a metal block from there and then you can search for the problem. So for this, these ultrasonic waves are being used. Okay. Then you must have heard about the reflection of light. Now we have to study about the reflection of sound. They rather apply the same principle, that when, as we have studied in the reflection of light, when the light travels and it hits an obstacle, it reflects back. The same thing goes off for reflection of sound. When the sound waves travel, it hits an obstacle and it is being heard back. So that is called as a reflection of sound, which can be understood by this simple experiment, that this is a wall, or you can say that they have kept an hard plywood, or you can even keep it against a wall. These two cardboard tubes which are hollow, from both the ends they are being opened, and you can arrange a soft wood. Okay, then at one end you have to keep a stopwatch, because it does that sound. Okay, you have to keep, it makes that tick 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 some sound it makes. And on the other end, other side of the cardboard tube, you have to listen to it. You have to arrange this cardboard tube in such a way that you are able to hear the tick tock noise. Okay, that you are able to hear the tick tock noise. So this shows what, that the sound wave which is being transferred from this, passes through the cardboard tube, it hits this hard plywood, and instead of coming back, what it does, it gets reflected back into this other cardboard tube, and you can hear the sound. So this is what is called as the reflection of sound. So even the sound waves, when they pass through, when they hit an obstacle, they are being reflected back in a particular angle. So imagine if this cardboard tube is little bit tilted this side or this side, would you be able to hear the sound? No, you will not be able to hear the sound. So like the reflection of light, even for the sound to be heard correctly or accurately, your angle of incidence, this is the angle of incidence, has to be equal to the angle of reflection, and then only you will be able to hear the sound correctly. Okay, so this is what is reflection of sound. So, like light waves, sound waves too get reflected from a solid or a liquid surface. These waves also follow the laws of reflection. A smooth or a rough surface is needed, uniquiet surface is needed for the reflection of sound. The direction of the incident sound wave and reflected sound wave make equal angles with the perpendicular to the surface, and all these three lie in the same plane. That means this is the normal, which is making a perpendicular, this is the surface, this is the normal. Okay, this is the normal, this is that surface which is making a perpendicular. Okay, this is the incident, and this is the reflected sound. Okay, this is the incident sound wave which is dashing to the surface, and the reflected sound is coming back to the other end. Okay, depending upon this, when we are talking about the surfaces, we have good reflectors and bad reflectors of sound. A hard and flat surface is a good reflector. Good reflector means it can reflect the sound, it does not absorb the sound, so that we are able to hear clearly. So while clothes, paper, curtains, carpet, furniture, etc. absorb sound instead of reflecting it, and therefore they are called as bad reflectors. So I'll repeat again, a hard and flat surface is a good reflector. Is a good reflector means they do not absorb the sound, but they reflect the sound. Okay, they reflect the maximum sound. But whereas this clothes, papers, curtains, carpet, furniture, etc., they absorb the sound instead of reflecting it, and therefore they are called as bad reflectors. If I have to give you all an example, in an empty room where there is no furniture, nothing at all, nothing at all, okay, no curtains, no bed, no cupboard, anything, the sound will be more. Okay, because it is a good reflector, there is no object, so wherein the sound would be absorbed. So that is why it is a good reflector of sound. Whereas in a room where there is a lot of furniture with the curtains and all, that is a bad reflector, because these cupboards and these curtains, they absorb the sound, and that is why this reflection of the sound is less. Okay, so in an empty room, the reflection of sound will be good, but in a room where a lot of furniture is there with the curtains and everything, the reflection would be bad. Okay, now when we are talking about this reflection of sound, echo is a very good example of reflection of sound to be understood. You must have gone to a hill station and shouted on the top of your voice, and you would have heard the voice again. Yes, that is nothing but an echo. So what is an echo? It is a repetition of the original sound. It is not that you just stand and wait for your own sound to be heard. No, you have to speak first. So that is what is called an echo, is a repetition of the original sound because of reflection by some surface. That means it has to have a surface so that it gets reflected back, and that surface cannot be anything. There are certain conditions for an echo to be heard. So first you understand what is an echo. It is an echo is a repetition of the original sound because of reflection of this sound by some surface. So this man is shouting, it produces the sound, the original sound. There is this surface, okay, it reflects back, and then echo is heard. He can hear the original thing. If it's suppose he has said hello, okay, so that is again heard as hello. Okay, so that is an echo. So for that you need require a reflecting surface. So understood, this is the definition of an echo. Okay, then what are the conditions which are required to hear an echo? Now I'm talking in the my house and explaining you all. There is no echo. Why? Because there are a lot of objects in my room, so they absorb the sound, and and there is no echo. Okay, so for an echo to be heard, there has to be a rigid, very strong and very large surface. Suppose you say something and against a marble or even a pen, that is not a very large surface, no, that the reflection of sound would occur. So for that you require a very large surface. Even the mountains which have lot of trees there, the echo would not be that much. For that again, because trees also absorb the sound, so that has to be a large surface of only mountains, then only you would be able to hear the echo. The temperature has to be distinctly around 22 degrees Celsius. Then the time, this is very interesting. The time should be more than 0.1 second. The reason is our brain retains the sound only for 0.1 seconds. That is, it only keeps in mind for 0.1 second. For example, if I say hello and after some point of time, okay, the other person says hello, so you would be able to distinguish between my voice and the other person's voice, isn't it? But if I keep on talking and the other person at the same time, then my mind is not able to distinguish between. So that is why it is said our brain retains the sound for only 0.1 second. So that is one more criteria. Thus, for us to able to hear a distinct echo, the sound should take more than 0.1 second, and after which, that is starting from the reflects from the source, that is I am talking, and again it is reflected back. Okay, I spoke, then 0.1 second, again it is coming back. So it has to be more than 0.1 second. I'll write here properly, more than 0.1 second. Okay, so you need to have a larger surface, stronger surface, and rigid. Temperature has to be 22 degrees Celsius, and time has to be more than 0.1 second. Why? Because our uh, brain retains the sound for only 0.1 seconds. Okay, then immediately it is ready for then another sound. And you all know that the velocity of sound in air, it is 344 meter per second. That is, in 1 second this 344 meter is being covered. So how would you calculate the distance? Now how much the distance has to be there for an echo to be heard? That we can determine by as distance is equal to speed in into time. So how much the speed is of the sound in the air? It is 344 meter per second, correct? And time how much it is? 0.1 second. So that is 34.4 m. Thus, how much distance it has to be there from, if I am standing here, suppose the surface from where the sound wave has to be dashed, it has to be, minimum distance has to be 17.2. Why? So it come 34.4, because once it is going, it is reflecting back, no, at the same distance, that is 17.2 meters, correct? So 17.2 plus 17.2 gives you 34.4. Understood? So the minimum distance has to be 17.2 meters. Okay, understood? No, why 34.4? Because when the sound wave is incident and it is reflecting back, so incident 17.2 meters it has to be there, the distance, but it is coming back, no, to you, so that becomes 34.4 meters. So thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is half of this above, that is 17.2 meters. As the velocity of sound depends on the temperature of air, this distance depends on the temperature. Okay, as the velocity of sound depends on the temperature of air, this distance also depends upon the temperature. I hope I'm clear with what is an echo. Okay, it is the repetition of the sound which takes place. It requires a larger surface area, the temperature around 22 degrees Celsius, time 0.1 seconds, and the distance 7.2 meters, and the velocity of the sound in air is 344 meter per second. There's an example given in the textbook which says that an echo can be heard multiple times due to the continuous or the multiple reflections. The Golguma at Vijapur in Karnataka is an excellent example of this. It is because of the structure, how it is made. You can hear the multiple times the echoes can be heard because of this structure. Then, what is reverberation? Now, there is a difference between an echo and reverberation. Echo is the continuous repetition of the sound, I would say, and reverberation is that you are not able to hear the sound properly. Whatever the reflection of the sound occurs, you are not able to hear them clearly. As in an echo, you can hear the sound very clearly. That is the difference between then echo and reverberation. Rather, if I have to be specific, echo would be repetition of the sound and reverberation would be overlapping of the sound. Okay, so now suppose this is a singer, okay, and you are the listener. So he is singing the song, so the sound waves are directly reaching him. Okay, you are able reaching you are able to hear it clearly, but at the same time the sound waves are traveling here, they are dashing here and there and again reaching. So the waves are coming from here also, the waves are dashing here and getting reflected to you also. So you are not able to understand, because the sound waves are coming from this and everywhere. They're dashing here, coming here. So see how many arrows they have shown. From here again coming to you, then from here again dashing here, then dashing in, and then coming to you, then straight coming to you. So it is the overlapping of the waves which occurs. Okay, so sound waves get reflected from the walls and roof of a room multiple times. This causes a single sound to be heard not once but continuously. Continuously you are able to hear the same sound, so you get irritated and you are not able to understand. This is called as reverberation. The time between the successive, that means one after the other, reflections of a particular sound wave reaching us becomes smaller. Okay, what it is reaching us after one after the other reflection, it becomes smaller, and the reflected sound, okay, whatever this reflected sounds, they get mixed up and they produce a continuous sound of increased loudness. which cannot be deciphered clearly. Deciphered means cannot be heard clearly. This is the reason why some auditoriums or some particular seats in an auditorium have inferior sound reception. Inferior means we are not able to hear them clearly. It is because of this reason. So how it can be avoided? That they need to have a dome shaped, they have to have a dome shaped auditorium, and the seats which are there, they have to be have the good absorber seats, good sound absorbing seats, so that the maximum sound is being absorbed and you can easily hear only the person singing. Okay, this was all about reverberation. Understood what is reverberation? It is a overlapping of the sound. Okay.